Okay, welcome to part 2. Okay, so in order to pinpoint more accurately where we think the median is, where the lower quartile, upper quartile, and anything else is, we need to draw a cumulative frequency curve. Okay, so what I've got here is the a data that I've already worked out what the cumulative frequency values are. Okay, and we are going to draw a curve based on this data. Now you must make sure you do it right. What you're going to do is you're going to plot the upper bounds against the cumulative frequency. And cumulative frequency will be your y-axis, and whatever you're measuring is going to be your x-axis. Okay, so in this case height is going to be measured, that's your x-axis. So what we're going to do is we're going to plot the cumulative frequency against the upper bound of that group. Basically what you're saying is there are 15 students that are up to 130 centimetres tall. So let's plot that first. So we're doing 15 against 130. 130, where exactly is 130? Let's make sure we do this right. My word, they've not done it very nicely. Is that 120, 125? I'm assuming that's 130. Oh my lord. How have they done it here? So I'm struggling to read the scale. Let's try and work out where 130 actually is. Assume it's there. 140, 150, 160, 170. Okay, so 130 against 15 would be there. 140 against 54. 140 against 54 would be there. Try and be as accurate as you possibly can. You lose marks if you don't put it in exactly the right place. 82 against 150. 150, 82. 150, 82 would be there. 160, 93. 60, 93 would be there. 170, 100. Okay, and then we're going to draw a curve. You can start from 120 and 0, because what you know is that there's no data below 120. So you can start it from 120, 0. And it'll have this kind of characteristic, kind of weird S curve. Okay, so you don't connect it up with a ruler, it's a curve. So no ruler. Now, so this is a cumulative frequency curve, and from this we can estimate the median height. Now, what we do here is if we want to estimate the median height, we look at the total frequency, sigma f equals 100, and we simply divide it by 2. So 100 divided by 2 equals 50. I'm not going to bother looking for the 50th and the 51st, because it's only an estimate anyway, so that kind of level of accuracy is not necessary. I'm just going to divide my total frequency by 2, and I'm looking for the 50th value. Okay, the 50th value is going to be my middle number. So now I go to my graph and I must draw in the lines. If you don't draw in the lines, you will lose marks. So I go to 50, go to the curve, and then read down and read off the curve. Okay, so I think, and if I read that as accurately as I can, I think the median height is 139.5 centimetres. That is where that green line is cutting the x-axis. Okay. Estimate the number of people. In fact, let's do B last. Actually, let's estimate the interquartile range. So what I need to find first of all is Q1. And that is going to be, well, I've got 100 bits of data, so I'm going to do 100 divided by 4 is equal to 25. So the lower quartile is the 25th value. So I'm going to go to 25, which is here. And I use a ruler, and I do it as neatly as I can. And I think that is going to be 2, 4, 6, about 133. Obviously, the scale on here is really annoying. I think Q1's about 133. And I need Q3 as well. Okay, Well, that will be the 75th percentile. So I'm going to do a 100 divided by 4 times by 3, which is 75, 75th percent. Okay, or you can do 0.75. So use a ruler. Oh, badly done there. Okay, and then read off where you think you are. So I think that's about 147.5. 147.5. Okay. So median 139.5, Q1 133, Q3 147.5. So the interquartile range is equal to Q3 minus Q1, which is 147.5 minus 133, which is 14.5. So interquartile range, 14.5 centimetres. So that is a measure of the spread of the data. The middle 50% of the data is only split apart by 14.5 centimetres. This data is quite packed together, you might say. Okay, I hope that makes sense. Now, when you do this, don't worry if you don't get exactly the right answer. The mark scheme will say as long as you put a value between 138 and 141, then you get the right answer. So, you might all disagree with each other about what the exact answer is, but as long as you get it in the right kind of range, it will make sense. The same with the interquartile range. Maybe if you said it was between 13 and 16, then you'd get the right answer. Okay, so any number between about 13 and 16, you probably would have been given the marks in the test, as long as you show those green lines. If you're lazy and you don't show the green lines, then you will lose marks. Okay? Oh, whoops, didn't mean to delete the cumulative frequency curve, so I'm just going to put that back in as quickly as I can. So 130.15, I'll just do it roughly. 140.54, 150.82, 160.93, and 170.100. Okay, and draw the curve back in. Okay, because we didn't answer part A. Part A said estimate the number of people at least 145 centimetres tall. Well, this time, start from the other side. You've got height of 145. So go to 145 for your height and read off. That means we think there are 70 people that are less than 145 centimetres tall. So the answer to that is we think there's 70 people. Okay? So we can use the cumulative frequency curve to estimate the median. We can use it to estimate the lower quartile, the upper quartile, and therefore the interquartile range. We can also use it to estimate other questions. We can't use a calculator. Okay, so let's just do a little check here. This cumulative frequency table shows information about the heights of students in a class. On a cumulative frequency graph, which point would be the correct point to plot for the highlighted rows? So remember what I said, it's always the upper bound by the cumulative frequency, not midpoints. You're not going to use midpoints here, and you're certainly not going to use the lower bound. So this one's wrong. Okay? And it's not this one either, because this one, you would be confusing it if you thought this was frequency. But this is not frequency, it's cumulative frequency already. So you plot cumulative frequency against the upper bound of the height. So the answer is C. Whoops. The correct answer is C. Okay, upper bounds against the cumulative frequency, not midpoints against the cumulative frequency. Many students make that mistake. Okay, so here's a question. In your books, see if you can draw an appropriate cumulative frequency curve for this, and then use your graph to answer the question. Hey, stop your video and have a go. Okay, this is, well, why can't I, there we go. This is what your cumulative frequency curve should have looked like. Use your graph to estimate the number of people who spent less than 24 minutes travelling to work. So they've shown the lines to show where that is, and then the answer is going to be 45 people. You must show those blue lines. If you don't, you lose marks. Okay, here's another one. So this time you've been given the frequency table. You first of all need to find out the cumulative frequencies and then make a cumulative frequency curve and then answer the questions. Stop your video and have a go. Okay, here are the cumulative frequencies, and next slide we're seeing the cumulative frequency curve. Okay. And so use a graph to estimate the number of people who took more than 35 seconds to swim one length. So be really careful here. The answer is not 15 because we want to know how many more, not how many people less. The answer to less is 15, so the answer to more is 40 minus 15, which would obviously be 25. So the answer is going to be 25, I hope. There it is, 25. So be really careful, read the question carefully. Okay, just have a little look at this one. Estimate the median speed of the motorists. Okay, you're going to do median. You've got 400 pieces of data, so you're going to do 400 divided by 2 is equal to 200. So you're looking for the 200th piece of data. Okay, read off. I think that's about 67.5. Okay, I was bang on. I didn't need to be bang on. Somewhere in that range would have been acceptable. Okay, interquartile ranges would be between the 300 for the upper quartile and the 100 for the lower quartile. So that's 25% value. So I'm thinking, what have I got here? 2, 4, 6, 7, about 73.5 here, and 62 for here. So I'm thinking Q3 minus Q1 equals 73.5 minus 62. I'm going for 11.5 as my interquartile range. Let's have a look. Wow, I was bang on. I didn't have to be bang on. If I'd have probably said anything between 11 and 12 or maybe even 10 and 13, I would have got the right answer. Okay? So you get a range for that. You don't have to be perfect. Depends on how you draw, how accurately you draw. Okay? So here we go. Let's try and put everything together. Stop your video and have a go. Okay, here's your cumulative frequency. Okay, you should have drawn the curve. Well, here it is. Okay, and so you can use that to find your medians and your quartiles. And so use your graph to estimate the interquartile range of the masses of cats. It said 1 kilogram because it's between 4.8 and 3.8. So well done if you got that right. Okay, right, let's explain the mistake here. Camila uses the data from a frequency table to make this cumulative frequency table showing the ages of shoppers visiting a store one morning. Even without seeing the original frequency table, how can you tell that Camila has made a mistake? Should be obvious. This number is less than this number. How can that be the case when the way you do cumulative frequency is you add on as you go? So that 45 can't be right. There can't be 45 people between 20 and 70 and 51 people between 20 and 60. Just a mathematical impossibility. Okay? So according to the table, there are 51 people aged up to 60, but only 45 people aged up to 70. It's just not realistic. It's not possible. Okay? Right. What we're going to do here, I've got a little challenge question for you here as an option. I won't give you the answer. Just have a look at it, read the question. If you want to have a go at it, then let me know on Teams if you get an answer, okay? So there we go. That's your introduction videos finished. Let me know if there's anything you don't